Good evening, everyone. Switch on your cams. Let's start off. Hope everyone went through the notes. The last class we are doing distances and displacements. Cams on, everyone. Others, cams on. Hridaya, Heath, Ekang, Shanai, cams on. Great. So let's start off with the problem. If your cams are not on, you'll be removed from the classroom. Great. So last class, what we have done, we just started with the basics in the last class, kinematics. We defined the distance, and these are the formulas for the distance. So distance is nothing but speed into time. But if speed is variable, then you have to integrate this. So distance is integral mod v dt. And for distance, another formula is integral root over 1 plus dy by dx whole square into dx. In case the equation of the path is given, and right, and they ask you to find the distance, this is the formula we have to use. So I think you can, anyone doesn't know this thing, there are few of you who are new, you can just note down these things in the red box. You can just put it down. So distance is speed into time. So that is integral mod v dt. Mod v is speed and v bar is velocity. And distance is integral root over 1 plus dy by dx whole square into dx. So dy by dx is slope. Shaurja, cam on. Clear? Let's go ahead. Let's start with the problem. We are still in the starting of kinematics. So the position vector of a particle r bar is given by t square by 2 I cap. So don't worry writing about too much of a theory and all. You'll be getting the PDF end of the session. So focus more on problem solving. Spend time on thinking and figuring it out. Any doubts, anything you didn't get, you're not convinced, please just unmute your mic and ask. It's a small group. Don't hesitate. But in case you're still feeling shy, you can always, type in the chat box here to the co-host. You got an answer, you can type to the co-host. So this is your position vector r bar. T is equal to time. Find the distance traveled in 2 seconds. And I told you last time, whenever you hear the word distance, have some fear. It's a trap. Let's give it a try. R bar is a position vector, which is depending on t square by 2 I cap plus t cube by j cap. So we are combining vectors, calculus, and kinematics. Heath, you need to keep your cam on. Dikshita, if your cams are not on, you'll be removed from the classroom. And do adjust your cam so that I can see your face completely, everyone. How do we do this? The position vector r bar is t square by 2 I cap plus t cube by 3 j cap. Find the distance traveled in 2 seconds. Try, you got 2 minutes. Be careful, it is distance. I'm not asking for displacement. Siddharth, do keep your cam on. Heath, I'll be removing you in a minute.
Yes, just 2 minutes.
Any answers, any ideas? Aryan, any ideas? It is position vector, right, Ali?
Yes, sir.
2y plus 8/3j. Ekank, I'm asking you distance. What are you giving me? How can your distance be in terms of I cap and j caps? You can't take T0. You can take T0. That has nothing to do with it, Ali. Answers, everyone. How do we do this? Anshul, Ekank, ideas? 10/3. That will be the first option in the exam, everyone, and you'll get a -1 for that. If you have got 10/3, you fell into the trap. It's a good one. This will be a proper advanced question. Now see, what most people do this thing. This is what they do. At T0, we get R bar is equal to 0, I cap 0, j cap. And at T is equal to 2 seconds, you get this will be your R initial. R final would be 2 I cap plus 8/3 j cap. Now, if you're doing delta R bar, that is R final minus R initial, which turns out to be 2I plus 8/3 j cap. Understand, this is displacement. This is not distance. And if you take the magnitude of this, what you get is magnitude of displacement, which comes out to be 10/3 meters. This is wrong. This is wrong. This is not distance. If they ask you to find displacement, you could have done this and you would have been right. How do you proceed from here? Siddharth, your cam is not on. Heath, you need to keep your cams on. I won't be repeating this 10 times. You guys know when the class starts, you have to keep your cams on. How do we proceed from here? Now let's take it in more detailed. If you guys are thinking it is online class, we can just come for time pass and all, I think you can leave the batch. I'm not looking at, people who are coming for time pass. You're serious about cracking the advance to be here. Heath, you need to keep your cam on or else I'll be just blocking you. Please don't join again. Better. So first, let's try to understand what is happening with the problem. Okay. Thing is, see, whenever you get a problem, don't directly jump into solving. First of all, try to figure out what is happening here. So if you take this R bar here, if you're just getting into problem solving, right, that is what is required in mains. But you're planning for advance, you need to have a deep thinking like, okay, what's happening with the problem? What is being asked? What information do I know? So if you look at this here, this is your x coordinate, which is nothing but t square by 2. This is nothing but your y coordinate, which is t cube by 3. That is a component of I cap and j cap. So from here, if I actually try to solve this, I end up with t is equal to root 2x. Take this and substitute in this y here. You get y is equal to That will be 2 to the power of 3 by 2, x to the power of 3 by 2 by 3. This is called equation of trajectory. So in this question, right, if I ask you this as a paragraph, I would ask you multiple things like this. Find the equation of trajectory. Equation of trajectory is nothing but the equation of the path in which the body is going. So, how is this path actually? So if you try to plot this y versus x graph, this is something like a parabola. This is how the curve looks. This is the path of the body. It is not going in a straight line, everyone. It is going in a two-dimensional x and y coordinates is changing. And what did I ask you? At t0, you're here, and t is equal to 2 seconds, you're here. If you did delta r bar, this was displacement. This is what you guys were finding when you subtracted the initial minus final. What I asked you was this green line, the distance, the arc. I hope now you're getting what I'm asking you. If you do delta r bar, r final minus r initial, what you're getting is the length of that red line. What I'm asking you is the length of the green line. The particle is going along that arc. Do have a look at this. Is this logic clear, everyone? I hope you're getting what is happening. Clear, Aryan, Anika?
Yes, sir.
Anuj, Siddharth, clear with this? Dikshita, clear with this? So now how to go ahead from here? Lakshika, Hridaya, clear? Ali, got the idea here? Sorja? Clear. So Hani, clear with this? Great. So, yeah. So how to find the distance? Remember the second formula? Distance is integral mod v bar, that is the speed into time. So we know r bar is nothing but t square by 2 I cap plus t cube by 3 j cap. So if I differentiate this dr by dt, I end up with velocity, which is nothing but t I cap plus t square j cap. Now I don't want v bar, okay? What I want is v mod v bar. So mod v bar will be t square plus t power 4 ka whole square. So what you have to integrate is, so this can be written as take out t common, you end up with 1 plus t square. This is the speed as function of time t. So putting this in the distance formula, you get integral root over 1 plus t square t into dt. Limits will go from 0 to 2 seconds because the distance is asked for 2 seconds. Now, how do you integrate this? We use something called integration by substitution. We have done this in calculus ka part, the last. So in this, the idea is, if you remember in calculus ka notes, what we did, this was one of the form. Sorry, here is the calculus ka notes. This is the first form. Root over x square plus a square x dx. Like I said in physics, right, there are 3 forms of integration which you need to remember of substitution. But anyways, I'll just show you. Put 1 plus t square is equal to some z square. That is some random variable. Differentiate both sides. So 1 ka differential is 0. T square will be 2t dt. This will be 2z dz. Now, the moment you substitute there, if you observe, it becomes so simple there. Z square ka root and t dt will be z dz. Your integration becomes integral z square dz. So you simply get z cube by 3. But what is your z? 1 plus t square ka root, that is 3 by 2 by 3. Substitute your limits 0 to 2 seconds. If you put the limits there, if I put 2, I get 1 plus 2 square, 5 to the power of 3 by 2. Substitute 0, there you get minus 1 by 3. This is your distance. That is the length of this green line we are talking about. Do have a look at this. So this is a combination of vectors, calculus, and kinematics. Again, the whole thing. So I gave you a position vector t square by 2 plus t cube by 3 j cap, and you asked me to find distance. If you do directly r final minus r initial, what you get is displacement. This is not distance, so be careful. If you actually try to draw the path of this particle, the I cap will give you the x coordinate and the j cap will give you the y coordinate. From there, I can eliminate time and I end up with something of this sort: 2 power 3 by 2, x power 3 by 2. This is called equation of trajectory, meaning the particle is going on a curve which is proportional to x power 3 by 2. So when you take initial to final, the red line here, what you're getting is actually the displacement. The green line is the distance. Now for distance, it is speed into time, but speed is not constant. So differentiate, get the velocity. Velocity ka magnitude is speed, then integrate mod v dt. And you can't integrate this directly. We have to use something called integration by substitution, where you replace this entire 1 plus t square with a variable called z square. Now, why do we have to do this? Frankly speaking, maths people will teach you that, but for physics, you need to know this. When you take 1 plus t square as z square, it comes out of the root. And second, this t dt will become z dz. So actually, it gets simplified. So this is something which you need to mug up. You need to remember this, that whenever you get an integration like this, you have to do this. In physics, you barely have 3 models like this. How and all, we are not interested. We are interested in how to apply this. We are not a maths class, so don't worry about it. So put it down. Ekansh, you can should definitely go back to the calculus notes and check it out again. We have done multiple of them in there, right? Do have a look at this. And let maths people teach you. Next year, they'll teach you calculus for 2.5 months. This is nothing. This is a joke there. This is like a small puppy. They'll teach you Godzilla there. And then you will feel, oh, physics integration was so nice. But for now, I know it'll understand like that. You can do that also, Ekansh. Once you know the equation of trajectory, you can put it in that slope curve formula and finish it off. But yeah. Clear with this, everyone? Any doubts on this? This would be mostly a paragraph question. I can ask you equation of trajectory, I can ask you distance. Any doubts on this? Pratyush, clear with this? Anay? Clear, no? Aryan, clear? Hriday? Dikshita? Can I go ahead? You can note down the main points there. Anyway, you'll get the PDF end of the session. So let's spend more time on thinking and solving. Let's see one more. Last class, we did still some basic problems. Today, it is like little higher level problems. Next one. We have a wheel of radius r. This is point A. A wheel of radius r rolls on a floor without slipping. Find the distance traveled by point A in one full revolution. Especially when you hear this word distance of questions, right? They're a little on the higher end. Find the distance traveled by A in one revolution of the wheel. Again, I'm telling you, when you hear the word distance, have some fear. Don't be in a hurry. Think, because you get trapped easily in one revolution. Think for a minute. Okay? Then I'll show you what is exactly happening. Then I'll give another 2 minutes for you to solve. Like I'm saying every time, don't be in a hurry to solve the question. Physics, if you're in a hurry to solve, you'll get nothing. First, read the question, try to understand, think of anything. Okay, aisa ho raha hai, it is happening like that. This, it doesn't matter. It always starts from there. It always starts from your thinking. Because if you can start thinking, if you can figure out things on your own, you'll be able to solve any question later on. Take a minute, just think about the question. And then we can discuss, and then I'll give you another 2-3 minutes to solve. And if someone had got the answer like this in an instant you messed it up. I know what you did. You don't need it. You can solve it. You do need a concept, but you really don't need rotational dynamics. And I mean, some of you are not there. We have done this, where in vectors. Anyone remembers? In vectors, we did this in the form of this question. A wheel is rolling on a floor. Find the position vector at time t. Remember this? There I taught you about this a bit. So we are doing it in more detail now. So what am I asking? I'm sure everyone studied this part. In one full revolution, the center of the wheel travels 2 pi r. I hope everyone knows that concept, right? We have done that in vectors also. So what am I asking here is, in one revolution, this point A from here goes here, but the A actually has traveled this way. This is your distance. This was your displacement. You're getting it? So what you learned was this. In one full revolution, the center of the wheel will travel 2 pi r. This was displacement. What I wanted to find is the length of the red line. Let me show you how the path looks. There. So when the wheel is going now, this is how the path looks. If you take this point as A, so this is how the path of A. This shape is called a cycloid. It is not a circle. It's called a cycloid. So we want to find the length of that red line. There's a distance traveled. I'll just write down the answer here. It's a good result which you can remember. Exam, you won't have time to derive. Distance is 8r. The displacement is 2 pi r and the distance traveled is 8r, the length of the arc. Now, how do you proceed from here? Think. Now, I hope you understood what I'm asking you. I'm not asking you the green line, the displacement. I'm asking you the distance traveled. The A actually goes in some kind of curvy path. That curve is called a cycloid. Think. Let me help you with little basics. So first thing, I'll tell you what we are using here, okay? We are going to use this formula. Distance traveled is 1 plus dy by dx whole square root dx. This is the thing which we have to use. Means I need to find x and y coordinates first of all. And then substitute in this formula and you'll get the answer. 1 plus dy by dx whole square dx. And how did I get this? Here we get the proof here. I took a small arc ds, dy and dx. I used Pythagoras theorem. I took out dx common and I got this. And ds is nothing but the length of a small arc. And when you add them, you get distance traveled. So see. First thing, let the wheel rotate by an angle theta. So if you take this point as origin, this point as A, so A has gone from here to there. And this angle was theta. And we know in one full revolution, right? Right, I can't. That only have to do. So in one full revolution, right? That is in an angle rotated theta 2 pi, you get a distance traveled of 2 pi r. So for an angle rotation of theta, this distance will be r theta. For one rotation, theta is equal to 2 pi. The center will travel a distance of 2 pi r. So for a distance theta, the center will travel how much? We can use unitary method. You end up with x is equal to r theta. So from here, we can find the coordinates. This is r. This would be r cos theta. And this would be r sin theta. So the coordinates of A will be, the x coordinate of A will be r theta minus r sin theta. The y coordinate of A will be r minus r cos theta. Basically, this height is your y coordinate. Please say how I got the coordinates. Once I got the coordinates, then I can just differentiate dy by d theta. That would be r sin theta. And I can differentiate dx by d theta. That would be.
Sir,
Ali.
sir, I did it d squared by dy square after differentiating.
Okay, Ali. So what are you trying to tell me? You got an answer? You can type in the chat box. I already wrote you the answer, right? Did you get that? Okay, then have some patience. No? Let others also listen. I know you got it. Please check everyone here. Everyone got the coordinates. Anyone didn't get the coordinates, please ask me. Clear, everyone? Anuj? Sohani, got the coordinates? Aditya? Hridaya? Hriday? So once I got this coordinates here, so y, just put on here again here, r minus r cos theta. And x would be r theta minus r sin theta. Differentiate this. Dy by d theta would be minus cos theta would be r sin theta. Dx by d theta would be r into 1 minus cos theta. So dy by dx, you can just divide them. Technically, you can't do that, but chalega, max physics mate works out. 1 minus cos theta, this turns out to be 2 sin theta by 2, cos theta by 2, and 1 minus cos theta will be 2 sin square theta by 2. And this turns out to be cot theta by 2. Now, using the formula for distance, integral root over 1 plus dy by dx whole square into dx. Substitute everything here. You get root over 1 plus cot square theta by 2 into dx would be r into dx again. This will be r into, that is 2r sine square theta by 2 into d theta. What is 1 plus cot square theta by 2? Cosecant square. You get cosecant theta by 2, 2r sine theta by 2 into d theta. Since you're talking for one revolution, theta will go from 0 to 2 pi. So this thing turns out to be 2r, one sine will cancel off. You end up with 2r sine theta by 2 d theta 0 to 2 pi. This integration would turn out to be 4r cos theta by 2. Let me show it on the next page. That would be 4r minus cos theta by 2. Limits will go from 0 to 2 pi. And that would be 4r. You won't get a minus sign. Or do I get a minus sign? I do get a minus sign. Yeah, I do get a minus sign. And substitute there, you end up with a minus sign, and this would be cos pi minus cos 0. Cos pi is minus 1, and 2, that will be 8r. That is your distance. Better to remember the result. Exam you won't have time to do, but it's a good idea there. because they can even ask a question like this: find the distance traveled when the wheel rotates 60 degrees. Then you just need change the limits from 0 to pi by 3. Again, look at what we did. First thing, you need to find the coordinates. Why? We are going to use the distance curve formula is this: integral 1 plus root dy by dx whole square into dx. So I need to find x and y in terms of theta first of all. So once I got the coordinates, I just differentiated dy by d theta, dx by d theta, divided them. I got dy by dx, and I got dx a value from here, and I substituted here. It just becomes a pure max question after this. Do look at the steps. It finally turns out to be a simple integral sine theta by 2. The result is pretty nice, 8R. That's the kind of question you can expect in bits or means a direct result. Advanced may they will twist it a little more. But how will you find time, Ekansh? Do it and tell me now. If you have some ideas, I think you should try and then you send me the working. Let me see. Problem is you'll be stuck without time. You're getting everything done so theta, isn't it? Then it is wrong, no? If you got R root 2. Clear with this, everyone? Do check it out. Yeah, this and the previous problem are a little heavy calculus based, but you do get this kind of questions also. Check any doubts on this. Once we got here, the question is over. So don't get confused between distance and displacement. Displacement is 2 pi r. That's what you have studied, I'm sure. Distance is a little different. Clear? Any doubts on this thing? Anika, Lakshika, clear? Aryan? Dikshita, clear? Siddharth? Next one. Let's do something a little more easy. Let me teach you one concept before going ahead. Helix. What's a helix? Anytime you have a problem, you want me to stop, please stop me. Don't hesitate. Just unmute and ask that, just go back, or you can just type me a message here in the chat box if you're hesitating to type in, talk in the mic. It's a small batch, meaning don't hesitate. Please do ask. You're here to learn, get things cleared. I'll be more than happy to help you out. If it's a big one, let's stay back after the class and discuss. Not a problem at all. How did you get 4R? You forgot how to integrate, Anika. Theta by 2, you'll get a 2 outside, isn't it? Sin ax plus b integration is 1 by a cos ax plus b. So here 1 by 2 is a 2 in the numerator. Do check it out. Integral of sine. So what's a helix? Best thing, you must have seen a screw. The threadings are actually a helix. It's a good one. This you will encounter in at least 3 chapters, so better know the concept. So if you take a rectangle and if you draw a diagonal, and if you fold this rectangle into a cylinder, then this red line will become something like this. This is a helix. You take a rectangle, draw a diagonal, and if you just fold it into a cylinder, the shape which you get is a helix. This is a one-turn helix, okay? This is a one-turn helix, single turn. And if you take this radius to be r and this height to be h, that means what will be the length of this rectangle? 2 pi r. And the height of the rectangle is h. Check this out. So this base here will be this circumference. This is how you get a helix. So know this concept. Clear? Let's see a question on this. Now, this is how they'll ask a paragraph. They'll explain you something like this, and they'll ask you something little different one. So, ever seen a car parking in a lot? It's like a cylindrical car parking. This is a, it's like a helix. So this is a, I didn't draw it well, like this. It's not proper, but yeah, bear with me. So this is a 3.5 turns helix. The radius of this car parking lot is r, and the total height of this car parking lot is h. So we have a point A here and we have a point B here. It's a 3.5 turns. So a car goes along a helix from A to B as shown. Find the distance and displacement. Remember this thing, huh? Again, we'll encounter this in laws of motion, then we'll encounter this in circular motion. Then again, we will see this in magnetic field. 3 more chapters will encounter this. From A to B. A is the starting and B is the end of that helix. Find the distance and displacement. Uniform circular motion will be slightly more easy, but let's see. You need to get used to this. Even in uniform acceleration motion, we are going to introduce a lot of variable acceleration stuff. You know what's a helix. If you make a 1-turn helix, it will be the diagonal of a rectangle. But remember, this is a 3.5 turns helix. So how do you handle this? Find the distance and the displacement. Displacement is easy. Try. You got 2 minutes, everyone. Ah, Pratyush. Displacement is right. Is it, Lakshika, what you typed is the displacement or distance? Distance, okay. 3.5. Nah, Lakshika, you goofed up that. That is wrong, Lakshika. Do check it out. Hriday. You divided the whole thing by 3.5? You might be right. Let's see. Let's square plus 12.25 r whole square. Why did you divide by 3.5? But okay, let's see. Once I do that, let's check it out. Distance is 1/5. Ekansh, how did you get 1/5? Did you get 1/5? Maybe you simplified in a different way, I suppose. Let's see. Siddharth, answers? Anuj, answers? Let's see. So first thing, now see, be careful here. So 1-turn ka helix, right, is what we proved here, that it's a diagonal is for 1-turn helix. So here it's a 3.5-turn helix. So how do we draw that? Now be careful here. See what is happening. For every 1 revolution, right, you come down by a height h, but here the total height is h. So this is point A and this is point B. Now be careful here. So in one turn, you travel a distance of 2 pi r. Isn't it? Every time you complete one turn, you travel a distance of 2 pi r. Then when you go for the second turn, so this is the first turn. The second turn, so let me just draw the complete thing. So second turn will be somewhere here. You will travel another 2 pi r. For third turn, you'll be somewhere here. You'll travel another 2 pi r. And finally, when you reach B, you're only doing half turn, which is pi r. Is that making sense, everyone? Every time you come down, you travel the horizontal distance of 2 pi r, 2 pi r, 2 pi r, and pi r. So the height will be decreasing incrementally. Height won't be h for everyone. And this total height is h. And this thing will be how much? 3.5 into 2 pi r, that is 7 pi r. So now if you fold this, this is the helix which we draw. So this is the first turn, this is the second turn, this is the third turn. Check. So the length of the green line is nothing but the diagonal of this rectangle. So distance will be root over h square plus 49 pi square r square. That's your answer. What about the displacement? Displacement is easy. You're starting from here and you're reaching here. The displacement is this red line. And this base is 2r and the height is h. So root over h square plus 4r square. That's your displacement and the green line is your distance.
So how did you got 2R?
Where diameter is 2r. Right? The diameter of the base is 2r. Do check it out. Is this what you guys got? I don't think so. Why are your answers so big actually? Hriday, that's not your answer, na? Is that the answer you typed? I don't think so. Somewhere it went wrong. Do check it out. See where it went wrong. Is this clear, everyone? Understood what we did? So every time you take a turn, the horizontal distance will be 2 pi r. So what I showed you here is for a single turn. But what if the helix has multiple turns? The total height is h. So that entire curve can be treated as a diagonal for this rectangle. Clear, everyone? Easy. Next one. Next thing, average speed. What is average speed? Total distance by total time. So this is integral mod v dt by integral dt. There is a distance by time ka formula directly. So 0 to time and 0 to time. Now the symbol for average speed, right? This is how we define average anytime. I'll tell you what is the symbol. So if you put something like this, right? This is the symbol for average. So example, if you say symbol of P, let's say P is power. What you're talking is average power. So any quantity that you keep between those two brackets, right? It is an average of that quantity. So if I say average velocity, so the symbol will be average V bar. Do you see the difference? The moment I keep a mod, it is average of speed. This is the average of velocity. This would be the displacement by time this would be integral v bar dt from 0 to time by integral dt. Check it out. So average velocity can be also written as delta r bar, change in position vector by change in time. Average speed and average velocity. Clear? Now here, this average velocity which we have taken, if you take for very small time interval, that is delta t tending to 0, the formula becomes v instantaneous. V instantaneous is the velocity at any given instant. So technically, this is how we should write. V instantaneous is limit delta t tending to 0. This becomes delta r bar by delta t. If you remember in differentiation, now this was the basic formula of differential. This is nothing but dr v by dt. So for very small time intervals, when you study, delta t becomes dt and delta r becomes dr. So this we define velocity as dr by dt. We have already used this, velocity is dr by dt, but this is how we get it. And what is the direction here? The direction of velocity v bar is tangential to the path. Whereas the direction of average velocity is in the direction of displacement. Let me give an example. So let's say a particle is going something of this sort. This is the initial position. If I ask you, find the average velocity when you have reached point A. So average velocity is what? Displacement by time. So you're assuming as if the body has gone from here to here, this is the average velocity direction. I'll just write V average. But if I ask you find the instantaneous velocity at A, this is the instantaneous velocity. At that instant, it is traveling along the path. Take one more example. If I ask you find the average velocity direction at point B, you simply take the from initial to B and join the line. That will be the average velocity direction. Whereas the instantaneous velocity direction will be tangential to the path. See, think about it. What is average velocity? So you are assuming as if you have traveled from initial to the final point within the given time. So you are assuming you have directly gone from O to A. So that is the average velocity direction. Whereas instantaneous velocity direction will be tangential to the path. Do have a look at this page. These statements are important. Let's see an easy version of this. Do have a look at this page. Anyone not clear with this? Anywhere confused? Please ask me to get it cleared. Clear? Let's see a question. All clear now? Anika, clear? Sorja? Dikshita, clear with this? Aryan? Ali? Clear? So a particle is traveling, let's say like this. This is the path of a particle. Starting from this point to. How many times does the average velocity and instantaneous velocity become parallel? So from later onwards, right, when we say velocity, it means instantaneous velocity. Every time we will not say instantaneous velocity. If it is average, specifically it will be mentioned as a question, find average velocity. How many times does average velocity and instantaneous velocity become parallel? So a particle is traveling from along the path from, let's say, O to A. Become parallel when particle goes from O to A. Let's get this. No, Hritin, that's wrong answer. Try others. Think, I'll give you a minute. How many times does the instantaneous velocity and the average velocity become parallel? Pratyush. Okay. No, Pratyush, that's also wrong. Ali, you said something, you're right. But let's see whether you did the same thing. Lakshika, you're right. Pratyush, you're wrong. Hriday, you're wrong. Anika, you're wrong. You have two right answers so far. Try everyone. You got a minute. You can type your answers in the chat box. That will be a good way for me to know that you're actually trying. Suhani, no, that's not the answer. Again, think about it. Ali, you need to keep your mic on mute, Ali. You're fighting with your brother. You can hear all the voices. Pratyush, you're right. Anika, you got it right. So what's happening here, everyone? Romer, what did I say? The average velocity is nothing but the direction of the displacement. Siddharth, you're wrong. So let me just show you the directions. You can figure out from there. For example, if I'm going from here to here, this is the average velocity, 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 average velocity. Can you see what is happening there? Again, average, 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 average. If you observe, whenever the average velocity vector becomes tangent to the path, that is, at this point here, this would be the average velocity. And at the same instant, the instantaneous velocity is also tangential, isn't it? This is a V instantaneous and this is V average. It doesn't happen here, everyone. This would be V average and tangential would be this way. It is not maximum minimum. I'm not asking you maximum minimus. You guys have people who said 5, you're actually finding the critical points, maximus and minimus. And this is 0.1. This is 0.2. It will be actually somewhere here. This would be the V average. This would be somewhere 0.3. And this would be 0.4. There are 4 points. So at this point, this will be the tangential, this will be tangential, and this will be tangential. So the answer is 4. So for these kind of questions, right, this is how you approach. You need to find the points, draw the lines from the, draw tangents from the curve A. Draw tangents from point A, sorry, from point O to the curve. So wherever you get a tangent at that instant, both will be parallel. At these points, instantaneous velocity and average velocity are parallel. The answer is 4. Clear? So you're not supposed to count critical points. People who said 5, you counted these 5 points. This point is useless actually. That won't be counted. It's not a critical point. All got this? Easy? I'll just give one more. No need to solve, but just tell me what is the answer for this. What will be the answer for this guy? We'll start from here now. 1, 2, 3, 4, 5, 6. Clear? Can you tell me how many times the average velocity is 0? How many times is the average velocity 0? 6 times. V average and V instance is parallel. How many times is V average 0? It's a different question. Anyone? Again, let's go back to the definition. What is average velocity definition? Displacement by time. Sorry, my mistake. This is not a graph, na? This is not a graph. I'm sorry. If this was a XT graph, then what I asked you would have made sense. My mistake. There's zero axis. I thought it was an XT graph for a moment. But I hope everyone is clear with this. All got this? Now, while taking averages, right, there is one more type of average. Generally, we don't use them, but better we know. There's something called a time average. So time average is integral v dt by integral dt. You're integrating or you're finding average as function of time t. There is something called position average. This is rare, but they can always ask you. Position average is you're integrating with respect to dx. Later on, we'll see a question on this, where you're integrating as a function of x. You can even find the position average. But generally in the question, if nothing is mentioned, we always take time average. Clear? So this is one thing. Clear? Let's see a question on these averages. Nothing. I'm just defining two things called, time average and position average. So time averages you integrate with respect to time, whereas in a position average you integrate with respect to position. Problems on this later on we will see, when we do the vertical projections. Meaning if I give you a function v is equal to something like 3x squared, and if I ask you average, you use this. Position average, time average. So there are two different things. Position average is little rare. Generally, they don't ask you. But then again, advanced, we don't know. They can always define it and ask you. We'll see a question on this later on. Let's see a decent question. We have a particle going in a circle with speed u. So this is your x-axis. This is your y-axis. So we have a particle here starting from r comma 0. At t0, it is here. A particle is going in a circle with speed u, constant speed u. Initially, it is at r comma 0. First thing, find the center is the origin for the circle. Radius is r. Find position vector as function of time t. Find position vector, velocity vector, acceleration vector at time t. Find average velocity and average acceleration. Just let me define that also. It is fine. Find average velocity at time t. Find d mod r by dt. Find d mod v by dt. Both are different. Don't get confused between dr by dt. Find d mod of dr by dt and d mod r by dt. D mod v by dt and mod of dv by dt. Integral mod v. Yeah, that is fine. I think let's get this three first. So you're putting differential of mod r. Second thing is mod of dr by dt. Both are totally two different things. These two are not same. First, let's get the position vector, velocity vector, and acceleration vector at time t. The particle is going on a circle with constant speed u. Position vector, how do you get that? Anything? Answers? Position vector and the velocity vector. Start doing. Anshul, answers. Pratyush says constituted by R, I cap. Pratyush, check your I cap ka thing. That is wrong. Minus sign matters. No, position vector, na? You're right. Yeah, you're right. I thought it's a velocity vector. Aryan, answers. We have one answer so far. Position vector is easy. Get it? Once you get the position vector, you can differentiate, get velocity vector. Differentiate again, you get acceleration vector. Find average velocity at time t and C part. Find d mod r by dt, mod of dr by dt, d mod v by dt, mod of dv by dt. So what is this dr by dt, right? Let's do more problems on that part. That's more interesting. dr cos theta minus r. That looks right. See, the first thing, the position vector. Let's say after time t, the particle has reached somewhere here, A. So this is your position vector r bar. This is angle theta. So from here, if I drop a perpendicular, I'll get the coordinates r cos theta and r sin theta. So the position vector OA bar is nothing but r cos theta I cap plus r sin theta j cap. But what is theta here? Theta is not given. How do you find theta?
Length of arc.
length of arc, you're traveling with speed u, right? So if you're traveling with speed u, time t, how much do you travel? In time t, you travel a distance of ut. And this radius is theta. And we know theta is equal to ut by r. That's how you find. That's your angle as function of time t. So your position vector r bar is given by r cos ut by r I cap, r sin ut by r j cap. You want velocity vector differentiated. Dr by dt would be cos ut by r, that would be minus u sin ut by r I cap plus u cos ut by r j cap. You want acceleration, differentiate again. This would be minus u square by r cos ut by r I cap minus u square by r sin ut by r j cap. If you observe this, if you remove u square by r common, you end up with the position vector r cap. And in school, we studied this: when a particle goes on a circle, the acceleration will be u square by r, centripetal acceleration toward the center. Check it out. So we got acceleration is equal to minus u square by r, and that would be r cap. Or you can simply write u square by r into minus r cap. This is your centripetal acceleration. So just to show you here, this is how the things will look. This was your r bar. This was your velocity. And this was your acceleration, which is u square by r and minus r cap, opposite to the velocity. This is your centripetal acceleration, which you studied in school. There, that's the first part. Second thing, find average velocity at time t. Do have a look at this page, everyone. Most common thing is you need to find the theta. Most people get confused in finding the theta ka part. Once you got that, it is simply finding the coordinates and then differentiating it 2 times to get velocity and acceleration. Clear, everyone? What is average velocity? Get the B and C part. Try. You got 2 minutes. Find average velocity at time t. Find d mod r by dt, mod of dr by dt, d mod v by dt, mod of dv by dt.
You explain acceleration only.
Acceleration, you just differentiated 2 times, right? Differentiate velocity again. So sine of ut by r is cos of u by r comes out, na chain rule. Siddharth. You're asking how did I get the differentiation part, or what you're asking exactly?
Right.
You forgot the chain rule, huh?
Yeah, I messed that up.
You have to differentiate what is inside again, na? When you differentiate sine ut by r, it will be cos ut by r into ut by r ka differential you have to do again. Chain rule. Don't forget. Get the average velocity, everyone. You got a minute. Keep going, keep going. This week a test, right, will be online tomorrow. I'll be sending a new test schedule. It got delayed a bit actually. This week it was supposed to be what? We'll be having a test on full vectors again. Vectors advanced paper will be there. Basic maths and vectors. The test this week got delayed actually. And last week results also have to post. Last week I fell sick for 3-4 days. Everything was a mess. We'll sort it out by tomorrow. You'll get the new test schedule and the paper will be online with the results. How do you find the average velocity? What's the definition of average velocity? Average velocity is displacement by time. So initially you are here. So the initial vector is nothing but r I cap. After time t, this is theta. This was your r final. This was your r initial. The result is important, right? Direct, mains or CET level question this was. This would be r cos theta I cap plus r sin theta j cap. It is important to do tough questions, but it is also important to know your standard models. Because end of the day, mains, if you're not scoring 99 percentile, what's the point of advance? So when you take the displacement vector delta r bar, you end up with r final minus r initial. So that would be r cos theta minus r I cap plus r sin theta j cap. So this is the position vector. Now this result is important. If you take the magnitude of this, you end up with r into root over cos theta minus 1 whole square plus sine square theta. Expand this, you get sine square theta plus cos square theta is 1. You'll get 1 plus 1 minus 2 cos theta. And take out the 2 common. 1 minus cos theta. 1 minus cos theta is nothing but 2 sine square theta by 2. You end up with, there's an r outside. 2r sine theta by 2. It's a good result. The displacement is 2r sine theta by 2. So you want average velocity. That would give me this formula here, delta r bar by time. You want magnitude, just take the magnitude of this and finish it off. Simple one. So if a particle rotates by an angle theta, the displacement vector is 2r sine theta by 2. Same thing you'll get for change in velocity also. I'll just write down that here.
I just did till means delta r vector. I did not found the model.
That is okay. That is okay. This is a change in velocity magnitude 2v sine theta by 2. This was asked in bits and mains before. Simple question. Find the change in velocity magnitude 2v sine theta by 2. Clear? What about this dr by dt and stuff? So I can do the same thing with change in velocity also. Change in velocity will be v final minus v initial. If you take the v final from here, you get the same stuff. Minus u sine theta I cap plus u cos theta j cap minus u j cap. You end up with u cos theta minus u j cap. This is a change in velocity. So if you want average acceleration, which is change in velocity by time. Just let me add that also here somewhere. Average acceleration is change in velocity by time. Fair enough. What about the C part? It's still not over. D mod r by dt, mod of dr by dt, and d mod v by dt. Try. You got a minute for that. Anyone confused till here? Anything you're not convinced? Please ask me. Get it clear. Ali, what happened?
Sir, nothing.
Here, d mod r by dt. So how to do this thing? Let's try to understand what each thing means. D mod r by dt. You know what I'm asking here? I'm asking you rate of change of length of the vector. You're getting it? I'm not asking you rate of change of vector. Both are totally different things. So what I'm asking is the change of rate of length of the vector. So when you're going in a circle, is the vector column changing? So if you see this r bar is changing, but mod r bar is constant. So what is this answer here? 0, isn't it? D mod r by dt is a rate of change of length of the vector. No matter how much the vector rotates, direction is changing, but the magnitude is not changing. Clear? What about the next part? So what is mod of dr by dt? This is speed actually. So magnitude of velocity, this is speed. Are you getting the difference? Both are not one and the same. Similarly, what is d mod v by dt? This is a rate of change of speed. This is not acceleration. How much is this? This is 0. Why? Speed is not changing. Speed is constant. But velocity is changing. What is magnitude of dv by dt? This is rate of change of velocity. This is magnitude of acceleration. I hope you're getting the difference. Putting the mod inside and outside will change the whole answer. Clear? So let's see in little more brief what is exactly this d mod r by dt. Can I turn the page? Any doubts on this? Anika, clear with this? Anuj? Aryan, clear? Anay? Aditya? Dikshita, clear? Pratyush? Ali? Anshul? Perfect. So a bit of a theory on this. So let's say if a particle is going in some random path and this is your position vector here. So let's say if this was your r bar, now try to understand here. And let's say this is your velocity vector v bar and this is the angle theta. Now, if you resolve the velocity vector into components, this component will be v cos theta and this component will be v sine theta. Now you tell me, what is v cos theta doing? The v cos theta is responsible for changing the length of the vector. The component of velocity along the r bar will be responsible for changing the length of the vector. Responsible for changing length of the vector. That is the meaning of components. The other component, v sine theta, this guy was responsible for changing the direction of the vector. So when you're writing this formula here, na, d mod r by dt, what is this? This is component of velocity along r bar. In vector form, we can write this thing as v cos theta, which is nothing but v. What is cos theta? R bar r cap dot v cap, isn't it? Do you remember that vector dot product thing? V bar dot r bar by mod r bar. Component of one vector in the direction of another vector. I'm sure you studied that in vectors. So this is an important thing. So when someone asks you what is d mod r by dt, what he is asking you is indirectly to find the component of velocity along r bar. Clear with this? Do check it out. This is the meaning of d mod r by dt. Remember this thing, huh? When we do projectile motion, this will come again. Then I'll show you. All clear? Perfect. Let's see an easy question.
Sir, one second.
Yeah.
Done.
Great. So we got that average acceleration part. Was change in velocity by change in time. So instantaneous acceleration a bar is given by limit when for a very small time interval delta t tends to 0, delta v by delta t. This is what actually becomes dv by dt. So we can write acceleration as dv by dt, or you can write it in another form. V dv by dr, but a better way of writing will be vx dvx by dx I cap plus v subscript y d subscript y by dy j cap vz dvz by dz k cap. So what is the meaning of this? This is the component of acceleration along x direction. This is component along y, component along z, and so on. Clear? That's about instantaneous acceleration. Let's see an easy question. A vehicle goes with speed v1 for half the time. A vehicle moves with speed v1. This is another standard question. for half of the total time. Then it goes with speed v2 for half of the remaining distance. So after traveling for half of the time, whatever distance remains, uska half, it will travel with v2. And v3 for the remaining distance. This is a standard question. Find the average speed. I hope the question was clear. Let's say if the total journey was 2 hours, you went with speed v1 for 1 hour. Example, just random example. Let's say total distance is 100 kilometers. You went with some speed v1 for let's say 1 hour, and you covered 40 kilometers. So remaining 60 kilometers, 30 kilometers you're traveling with speed v2, remaining 30 you're traveling with v2. I hope you're getting what I'm saying. Find the average speed. Get this one.
Sir, can I explain what the question is?
There, see, it is written in clear English. I know my handwriting is not that great, but please do read, because final exam no one will come and explain you the question. This is the question. Think, take a minute. If you still don't understand, I'm there, but you put a fight now, first of all. If you start taking help immediately, you'll never become strong. I'm there, but you try, read. Make your school proud, especially your English teacher. He might feel bad. Understood the question? Should I explain? Understood? No, it is important, right? You know, the language, right? If you observe in a 3-hour paper, on an average, a student takes 40 to 45 minutes in reading the questions. So reading is actually a pretty important skill. And exam, there'll be, you know, teacher won't be there beside you to help you out with the words. Try, take a minute or two. I'll show you this how to do. It's a good one. 2v1 v2 plus v2 by nah, it looks weird. No, that's not the answer. v1 plus 2v2 plus 3v. Where did you get from 1, 2, and 3 numbers? Maybe are you saying v? I think maybe you meant 3v, v3. I don't know. Maybe you typed it little weird. Any other answers?
Sir, you're telling me?
Try. I'll give you a minute more. You need to solve a lot of questions, Ekamsh. That is one, especially like, you know, I'll tell you, I'll talk to you later after the class. Any answers? Aryan, today you're totally silent, no answers. Tired from major test. Solve. Other people are exhausted from the major test. Possible. v1, v2 plus v1, v3 plus 2, v2, v3 by Lakshika. You might be right, but denominator you got only v2 plus v3. Yeah? You might be right, but I think you should get half also. Can you check? I think your 2 is missing. Got it? There's an overall 2. Should I help you? It is not that clean actually. It is just lengthy. It is not tough, but it is lengthy. Don't get confused between a tough question and a lengthy question. Tough question is something which doesn't even click what the hell is happening. Lengthy questions are just lengthy. You just need to sit and just silently solve. Let the total time be t. Okay. So you're traveling for half of the time. So t by 2 till here. So this thing will be v1 t by 2. And let the distance, right? You're saying you're traveling for equal distances after that. So let this be v3. Let this be s. And let this be s. I don't know how much is s. I don't know what is time. I just eliminated them all. Because the second part of the question is you're traveling in remaining equal distances, half of distance with v2 and v3. Half of the remaining with v2, half of the remaining with v3. So what is the time here? So this thing will be s is equal to v2. Let's say some time, I'll just call it t2. And this would be s is equal to v3 and time t3. Time may not be same. And from here, and I also know from here, t2 plus t3 should be equal to remaining half of the time, isn't it? If this total time is t by 2, then this total time should be t by 2. And from here, we know v2, t2 is equal to v3, t3. So from here, I get the ratio of t2 by t3 will be v3 by v2. I can substitute here and I end up with take out t3 common. You get v2 by v2 plus v3 into t by 2. That is the t3 ka value. Similarly, t2 ka value will be v3 by v2 plus v3 t by 2. This is the value of t2 and t3 in terms of this. And what is the average speed? Average speed is total distance by total time. What is the total distance? v1 t by 2 plus v2 t2 plus v3 t3. And what is the total time? T. So from these two, t3, t2, take it and put it in this. Have a look at the steps still here. Dikshita 2 v1 v2 plus. That is wrong, right? Ali, you're wrong. Dikshita, you're wrong. Anika, look at your answer. The moment you say an answer, you can tell your answer is fine. You changed it. You forgot it too. Do check the steps still here. I think once you take T2, T3 and put it here, you'll get the answer. Let me show you in the next page, but do take a minute to see what I did here.
I got confused in the English.
We have to be careful. Right? This is something, which when you solve questions, you will understand this. So people who are having a problem like that, reading questions, you can take Resnick and Halliday and you can just read the questions and try to understand them. Don't solve. Resnick Halliday is a good book, but the numbers are bad. You can do that. You can read, these books by foreign authors. Or best would be, what? Take Erudo and try to read the questions. It's a Russian author, which is, book is translated into English. English is hopeless. Even I don't understand sometimes. Helps a lot.
The Erodov first or second question is like this only.
I know. First question only, you don't understand what the hell is happening. Hi, Akash, you can try that.
No, that I could solve, but that was very easy, sir. Normal question.
Try that, physics is a good book. It's like, don't make it like an everyday thing. Maybe once in a week, we can sit for half an hour, 45 minutes, just go through that. Helps you to build up. Now let's substitute here. Average speed. This would be v1 t by 2. I don't have a problem with t. I have a problem with t2 and t3. v2. And what is t2? T2 is v3 by v2 plus v3 by t by 2. Like I said, numbers are not good. v3 and this guy would be v2 by v2 plus v3 t by 2. I hope I'm right. Yeah. By overall t. Did you see t gets cancelled everywhere? And you're left with, take out that half common. You get v1 plus v2 v3 by v2 plus v3. and that also V2, V3. So that will be 2 times. So just cross multiply. You end up with V1, V2 plus V1, V3 plus 2 V2, V3 by V2 plus V3. That's your answer, everyone. Do check. So the main thing is getting T3, T2 in terms of T and putting it in the formula. Clear, everyone? Easy? This is a lengthy problem. It is not tough. Just brute force. Clear? Can I go ahead? Great. So that is about a bit of distance, displacement, and average velocity. The next thing will be uniform accelerated motion. We'll just finish out the theory today. Next class we'll do more problems. So when you say uniformly accelerated motion, meaning you're saying acceleration is A is constant. You need to know how we derive the 3 equations. Later on, when we do non-uniform motion, you'll understand. So we have A is dV by dt, which is constant. So we can write dV is equal to A dt, integrate on both sides. So here U is your initial velocity. V is your final velocity. S is your displacement. Which is nothing but R final minus R initial. So this would be from 0 to time. This will be from U to V. This integral will be V minus U is equal to 80. So V is equal to U plus 80. This is how you derive the first equation. You can also write this in the vector form. Then if I integrate this again, this would be dr by dt will be U bar plus A bar into T. So dr bar will be U bar into dt plus A bar into T dt. Integrate on both sides again. This will go from R initial to R final. This will be from 0 to time and 0 to time. This would become R final minus R initial. This will be U bar into time plus half A bar into T square. This becomes displacement vector S bar is equal to U bar into time plus half A bar into T square. If you just remove the bar on the top, it becomes a one-dimensional motion. This is a second equation. And we know acceleration is V dV by dr. So if you can just shift that side, V dV is equal to A dr and integrate on both sides. U to V and R initial to R final, you get V square minus U square is 2A displacement, R final minus R initial. This is the third equation. So these 3 equations, right? We didn't just get them in thin air, we actually integrated them to calculate it. Do have a look at this. It's important because later on, we will do questions like this. A is not constant, A is changing with time. Then you should know what to do. Basically, in this place, you'll get A is equal to time, and when you integrate, right, A won't come out of the integral. I hope all are clear with these 3 basic equations, right? You must have seen this multiple times. But that's how we derive. And we follow sign convention for 1D. We take up as positive, the right side as positive, left as negative, and down as negative. We will stick to this convention strictly for everything. So if something is going like this, u 10 meter per second, and a is backward 2 meter per second square. So in the equation, we keep u is plus 10 and a is minus 2. Let's say a body is going down with u 2 meter per second, and acceleration is also down 3 meter per second square. I know in school you must have studied, in the direction of acceleration positive, but let's keep it simple: down negative or positive. U is minus 2 and A is minus 3. So keep the convention pretty straightforward. This is the convention which you will use throughout the mechanics in laws of motion, friction, every chapter: up positive, down negative, right positive, left negative. Clear with this? Great. Okay. So I think, so next class when we meet, we'll continue from here. So next class, we will be doing 1D motion, horizontal direction, then one vertical direction. So that should take another 1.5 class. We'll finish off with 1D and then we'll go off with projectile motion. Since you guys are already little comfortable with this, I can skip some easy problems and we can go for tough ones directly. So normally what we do 10 problems, we'll do 3-4 easy ones, 2-3 moderate ones and 3-4 tough ones. But since kinematics, I'm sure most of you are done. But again, don't worry, I'll be teaching you as if you don't know anything. Every chapter that I start, I'll always start from scratch, ground zero, as if you don't know anything. But I hope these equations you're comfortable with. Okay. So with this, we'll wrap up for the day. So we'll catch up on Friday again, as usual, same time, 8:45. So we'll continue from there. So do make sure to do the problems that we have done today, especially the first two problems we did based on integrations. Try to do them on your own again. It helps you, It is not that you're, just mugging up, but it is important that how did you take the steps? How did you integrate? That is something which you need to kind of get used to. This level of calculus comes a lot in physics advanced, especially. Mains may they don't have such high levels, but advanced, you should be quite comfortable with the calculus part. Okay. So I think with that, we'll wrap up for the day. So any doubts, anything, you can stay back or else you're free to leave. So take care, stay safe. I'll see you on Friday at 8:45 as usual. Any doubts, please do stay back and ask.